Hello. Alright, kids. So let us continue with what we had started. So we had done till here, if you remember. Huh? We found out that 1 joule is equal to 10 to the power 7 ergs. Right? Alright. So let's go ahead. And there are few more problems. Let's complete those also. And then we'll end this. Now, acceleration due to gravity is 9.8 meter per second square in MKS system. What is its value in CJ system? So again, the same type of question we have, that number into unit written in CGS system is equal to number into unit written in MKS system, right? And how am I getting this? You can see we made a formula for this in the last class. Here. We made this formula in the last class, right? NCUC is equal to NMUN, and then I'm going to use that itself. NCUC is equal to NMUN, you know? And then they have given me 9.8 meter per second square. What is this given? Number written in which system? Meter per second square means MKS into meter per second square. This is given what? Unit. Unit written in MK system. What is its value in CGS system? Right. So CGS we have to find out. Now looking at the units in the MK system, meter per second square, can you guys find out what will be the unit in the CGS system? Will be how much? So CGS means centimeter, gram and second, right? That means our meter is going to be replaced with centimeter, and second square is going to be replaced with second square as it is, right? And that is your UC. And we have to find out the value in CJ system. Value means the numerical value in the CJ system, means you have to find out this value, numerical value in the CJ system. And what is that coming out to be? Nm divided by UC. Okay, let's put the value. Nm is how much? 9.8. Um is how much? Meter per second divided by UC. UC is how much? Centimeter per second. And then that gets cancelled, meter gets cancelled, and what you're left with is 9.8 divided by C. And what is the value of C? C is 10 to the power minus 2, which goes in the numerator and it becomes 9.8 into 10 to the power 2, which is basically 980, right? So this value of 980 that we have got, we can take and put it back here to get the entire equation, which tells me that NC, which is 980, into UC, which is centimeter per second square, is equal to Nm into Um, and Nm is what? 9.8 meter by second square. So we get that 9.8 meter by second square is actually 980 centimeter per second square, right? Take this one. Alright, so let's go ahead with that. Gravitational constant. So in the same way you have to convert gravitational constant, which is capital G, 6.678 to 10 to the minus 11 meter cube per kg per centimeter per second square. It is again an MK system. You have to convert it into corresponding CJ system, right? So that you can try as a homework. You have to do the same way in which we did this question. The same way you have to do this question also. So we are towards the end of the chapter, right? You can do this. You can try these problems as homework so that we can move to the next chapter. Okay, one more question we'll do of this type, and then we'll move to the next chapter. You know? So one more question we'll do. One or actually two more questions. So today we'll do the questions only. Today we'll complete all types of questions in this chapter, and then next time onwards we'll be moving to the next chapter, right? So that's a plan. Okay. So in a new system of unit, the unit of length is 10 meter, mass is 10 kg, and time is 1 minute. Then what is the unit of linear momentum in this new system? So let us understand what they're saying. In this new system of units, unit of length and mass and time is different. Then what is the unit of linear momentum in this new system, right? So we know that n into u is a constant, right? So n into u is not going to change, you know. So n into u written in MK system will be equal to n into u written in which system? In CJ system. But it is also equal to n into u written in which system? In the new system. So n into u is not going to change. It is going to remain n into u only. So n into u written in MK system is equal to n into u written in the new system also. So how you'll go about it? Take some time to think how you'll go about this question. You have to apply the same logic what we have been doing. And they're talking about linear momentum, right? Which is represented by the letter P. So what is linear momentum? P is equal to, mass into velocity. And unit of P is, what will be the unit of P? Mass into velocity. No? So it is kg into velocity means meter per second. So that is the unit. Right? Now we want to write the same thing but in the new system of units. Right? So momentum is what? kg into meter per second. And that's equal to number of numerical value on the new system multiplied with units in the new system, right? Now let's find out unit in the new system will be what. So first term is kg. Instead of kg, what we'll have? 10 kg. Instead of meter, what we'll have? 10 meter. Instead of second, what do we have? 1 minute. Right? So I hope all the terms are clear. 10 kg, 10 meter, and 1 minute. That is the unit written in the system, in the new system, because kg has been replaced by 10 kg, meter has been replaced by 10 meter, second has been replaced by 1 minute. As they told, I've done. Right? And that value I can take and put it here. But I don't know nn, that I have to find out. So let's try to find out nn. So I get kg meter per second is equal to nn into un. But what is un, guys? Un is 10 kg into 10 meter divided by 1 minute. 1 minute is nothing but 60 seconds. But of course, then you get things getting cancelled. You have kg out, meter and second also gets cancelled. And you get a 1 here, right? And of course, this also gets cancelled. And you get 5 by 3. So what is nn coming out to be? Nn is coming out to be 3 by 5. So the number that we are getting is 3 by 5. So which option we are getting, guys? 3 by 5 means. Got it? So the unit of linear momentum is what? Okay, they're asking the unit of linear momentum in this new system. Unit of linear momentum in this system means we have got nn, and they are asking the unit of linear momentum in this new system is they are asking un, right? So un also we have already calculated. So they're asking the unit, right? So it's we have found out the number, but unit will be what? Unit is this. That is 10 kg into 10 meter divided by 60 seconds, and that gets cancelled, and you get 5 by 3. So 5 by 3 kg meter per second. They're asking the units. They're asking the unit. What is the unit? So unit will be what? Unit will be 5 by 3. 5 by 3 will, this will be the unit, and this will be the number. If you want the number, it will be there, right? But they're not asking the number. Take this down. This you have to do if you want to find out the number, right? We don't need the number here, so this part is not required. Just the unit is required, that we already have there. right? So now let's go ahead. We'll do this another question. Match the quantities from the two lists which have the same dimensions. So what is the dimension of angle? You know, theta is equal to L by R. So dimension of theta will be what? Dimension of L divided by dimension of R. And you know L means length. So it is length upon length, which gets cancelled and you get 1. It is like saying L to the power 0. That is theta, right? What about solid angle? The formula for solid angle is area by radius square. And if you talk about unit of ohm will be area, which is L square. Radius is also L square, right? Radius square is there, so length square. That will again get cancelled and you get L to the power 0. So we are directly getting that theta and ohm have got the same units, right? Same dimensions also. Which option we are getting? A matches to 3, right? And that is your first option. And also a fourth option, right? A matches to 3. Now we have to check one more. So we'll check C, work. Now work is what? Work is force into distance, right? And force is, as you know, MLT minus 2 and distance is L. So it becomes ML square T minus 2. That is work. ML square T minus 2. Now which other quantity have the same dimension? We know work and energy have got the same dimension, right? Work and energy have the same dimension. So this also has got same dimension of this, right? So which option we are getting? For C we are getting 1. So C we are getting 1, which is correct. So fourth is correct and first is wrong. Right? Fourth option is correct. Take it down. So let's go and do more questions. As we said, we'll be doing questions only today. So let us do this question also. This one, gravitational constant question also we'll do, and then we'll do one this question also. Let's start with this one. In a new system of unit is proposed in which unit of mass is alpha kg, length is beta meter, and time is gamma second. What will be the value of 5 joule in this new system? So 5 joule will be how much? Right. And we know any quantity is what? N into U. So 5 joule will be how much in this new system of unit? So that means we want to find out N and we want to find out U, right? And the quantity that we have is how much it is? 5 joule. And we have to find the number, we have to find the unit, both. So let us start with joule means what? Joule means it's a unit of energy. So what will be the dimension of joule? That's energy. So it is mLT minus 2. This is the dimension of joule, energy, ml square T minus 2, right? So what will be the unit in the MK system? M will become kg, L will become, length will become meter square divided by second. So this is the unit in the MK system, right? Similarly, what will be the unit in the new system? In the new system, what will be the unit? So instead of kg, what will come? Instead of kg, we have alpha kg. Instead of meter, we have beta meter. Instead of second, we have gamma second. Ka whole square. Right? And what is this equal to? Kg meter square per second square. That is nothing but the energy unit. That is joule, right? And we have to find the value of 5 joule in the new system. Value means numerical value you have to find out. Means which term you have to find out? N in the new system. Nn you have to find out, right? So 5 joule is equal to Nn into Un. So you have to find the value of Nn. So what is Nn coming out to be? 5 joule divided by Un. 5 joule. What is joule? You say joule is kg meter square divided by second square. Whole divided by Un. What is Un? Let's put the value of Un. This is the value of Un, which is alpha kg into beta meter whole square divided by lambda second whole square. See, I write this as lambda, even though it is gamma, no? I write it as lambda, right? So if I simplify all this, I should get the value of N, right? Let's do that. So that's equal to 5 kg meter square by second square divided by alpha kg beta square meter square divided by lambda square second square. And then of course you get terms getting cancelled. Kg, all the terms get cancelled. So what do you get? Lambda square goes in the numerator. That becomes 5. This goes in the numerator. 5 lambda square divided by alpha beta square. And then of course then you can simplify it. Or you can leave it like this. That is your number in the new system. Right? Take this down. Okay, so let's go ahead. Let's do this question now. Capital G is the gravitational constant. We have to write it in the CJ system because right now it is given in this system in the MK system. Meter, kilogram, second is MK system, right? So let us write the same thing but this time in the CJ system. So how do we do that? How do we go about it? So again the same thing, you see, over and over again we are doing the same thing. There's nothing new we are doing. Every time I write n into mks is equal to into u into mks is equal to n into cjs into u into cjs. Every time we have to do this, all like in this type of question. This is the one formula that we have to use and get all our answers. And you have to find the value in the CJ. Value means numerical value, right? Numerical value in the CJ system means you have to find this value. N CJS you have to find this value. N CJS is coming out to be NM UM divided by UC. Right? Just plug in the numbers, you get done. So this is the number N in the MK system. Actually, the entire thing. This entire thing, right? That's the number in the MK system. And this is the this is the unit in the MK system, right? Just put it there and divide it by UC, you will get NC, right? So it's very simple, straightforward. So that is the unit in MK system. What will be the unit in the CJ system? Now tell me. Meter in CJ is centimeter, whole cube. Kg to the power minus 1. You know what, actually I should write that UM properly because it is minus 1 and all, no? So let's first write UM properly, then we'll write the other one. UM is actually what? Let's write it properly. Meter cube upon kg upon second square. Now we can write CGS, unit in CGS. Meter will become centimeter cube by kg. Oh, that's it. Meter will become centimeter, right? Kg will become gram into second square. Got it? Now you can simplify it. That will be centimeter cube means centimeter whole cube, right? I've told you this centimeter cube means centicube, meter cube, both are there. So that will become centicube, meter cube divided by gram into second square. Now let's start putting in the values to get our value of NC, which is coming out to be NM, NM, NM. I'll just leave it like that right now. Let's see UM. UM is what? Meter cube divided by kg into SQ. Whole divided by UC. UC is how much? Centicube, meter cube. Whole divided by gram into second square. And then we get cancellations. Right? And that's equal to Nm divided by K into C cube. Got it? That's NC. K is 10 to the power 3. And centi is 10 to the power minus 2. Whole cube. That will become 10 to the power minus 6. Divided by 10 to the power 3 minus 6 is minus 3. So that gives in the numerator and becomes Nm into 1000. Right? So Nm into 1000. So what is the value in the CGS? Whatever you are getting into 1000, nm into 1000. And what is nm? 6.67 into 10 raised to the power minus 11 into 10 to the power 3. So that will give you 6.67 into 10 raised to the power minus 8. So that's the value we wanted to find out, right? Take it out. So we have time for one more problem. Take it down, then we'll do one more question and we'll end this. Now we have covered almost all type of questions, you can see, right? All the questions also we've done. Okay, this question we're not done. Let's do this also. SI unit of length is meters. Suppose we adopt a new unit of length which equals to x meters. So this is a new unit of length, right? Let's call it uh, unit new unit is x meters. And this one is which unit? SI unit means MKS, right? MKS is meter, whereas new unit is this. Area of 1 meter square expressed in the new unit has what magnitude? Actually, it should not be magnitude. That's a wrong question. It should be numerical value, number. Magnitude is wrong because magnitude also contains unit, but you see none of the options have units, right? So that means that they are actually asking the number and not the magnitude, right? So the unit 1 meter square expressed in terms of new unit has a numerical value or number how much, right? So as usual, we know that number written in MKS into unit written in MKS is equal to number written in the new system into unit written in the new system, right? We have been using this time and again. And also, you know, in CGS also you can write it as number written in CGS into unit written in CGS. That's all good, right? But right now we just need the number written in the new unit, right? And how much is that? Of course, it is NN is equal to what? NM UM divided by NM UM divided by UM. That's it. So just simplify this, you'll again get the answers, right? Same thing over and over again we are doing. Let's do it. NM. What is the number written in the MK system? So see guys, area is this, you know? So this will be the number written in the MK system, and this of course is the unit written in the MK system. So you get NMUM is what? 1 meter square divided by UN. You know? So what will be the unit in the new system? Let's write that. So this is the unit in the MKS. So looking at this, what will be the unit in the new system? Instead of meter square, it will be what? X meter square, because length is X meter. In MKS, what was the unit? MKS unit was meter square, right? So here what will be the unit? Here instead of meter, we are using what? X meter. So it will be X meter ka whole square, which will be equal to X square meter square. And that value of UN you can take and you can put it here. That becomes X square meter square by X square. Okay, that is it, right? So that's pretty much it for today. End it. And then from tomorrow onwards, we'll be having we'll be starting with a new chapter, which is vectors, right? That's even more important because that is completely related to the physics part. This is not very much related to the later physics part, but vectors is very much related and it's a bit difficult also, so you have to pay a lot of attention, right?